determine the correct size of an RHW aluminum conductor for the specified motors, let's break down the calculation step by step. The motors are 230 volts, 3-phase, and rated at 7.5 horsepower, 5 horsepower, and 2 at 25 horsepower. First, we need to find the full load current in amps for each motor. Using the appropriate NEC table, the full load current for a 7.5 horsepower motor at 230 volts is 22 amps. For the 5 horsepower motor, it's 15.2 amps. And for each of the 25 horsepower motors, it's 68 amps. Next, according to the NEC, we must take 125% of the largest motor's full load current. In this case, the largest motors are the two 25 horsepower motors, each drawing 68 amps. So, 125% of 68 amps is 85 amps. Now, we add this value to the sum of the full load currents of all the other motors. That means we add 85 amps to 22 amps, 15.2 amps, and 68 amps. This gives us a total of 190.2 amps. This total current is the minimum ampacity the conductor must be able to handle. We can round up to the nearest standard of a current protection device, which is 200 amps. Now, we refer to NEC table 310.16 to find the appropriate conductor size for an ampacity of 200 amps, considering that we are using RHW aluminum conductors. Looking at the aluminum column in table 310.16, we find that a 250 kc mil aluminum conductor is rated for 205 amps at 75 degrees Celsius. However, remember that we are looking for the next larger size in the table. Therefore, a correct answer for the size of the RHW aluminum conductor required is 400 kc mil, as 300 kc mil is rated for 175 amps, which is too low, and 350 kc mil is rated for 195 amps, which is still too low. Now, if you are using copper conductors, the 350 kc mil would be the size of the copper conductor required, not the aluminum conductor. Aluminum conductors require a larger size for the same ampacity compared to copper, due to their lower conductivity. Always double check which type of conductor you are using and select the appropriate column in the NEC table. Remember that accurately calculating motor loads and selecting the correct conductor size is crucial for ensuring the safety and reliability of electrical systems. Neglect in this step can lead to overheating, voltage drop, and potentially hazardous situations. Understanding and correctly applying NEC tables is a fundamental skill for any electrician or electrical engineer. In summary, firstly, determine the full load current for each motor from the NEC tables. Secondly, calculate 125% of the largest motor's full load current. Thirdly, add this value to the sum of the full load currents of all other motors. Fourthly, refer to NEC table 310.16 and select the appropriate conductor size based on the calculated ampacity and the conductor type, either copper or aluminum. Fifthly, remember to choose the next larger size in the table for aluminum conductors to meet the required ampacity. By following these steps carefully, you can avoid errors and ensure that your motor calculations are accurate and compliant with electrical codes.